Hello, dear student. I hope all of you are fine at home and preparing regularly. I have been since last 2 week that you guys are not watching the videos regularly. All of you are watch the video, but not completely. What happened to you guys? It's the peak time to be serious. If you are not serious at that moment, you'll never be serious about your career, about your life. It's the perfect time to be serious, study regularly, do the homework regularly, watch the videos regularly. If you have any doubts, directly you can call me. I am always ready. I am waiting for your call. None of you called me since the March of 21st when I start the online classes. I did not get any call from you. Some of you sent me messages regarding the doubts, but none of you have called me. I already told you that I am ready to take the video class if you have any doubts, to clear your doubts. So guys, be serious and attend the class video lecture regularly, not casually. When I asked you, you guys told me that you were watching the videos of vector. I have already completed the vector. Now you are watching the vector. You are delayed. So you overcome that delay and be regular, guys. Regular and punctual হোৱা ট্ৰাই কৰা তোমালোকে এইটো টাইমত যদি নোহোৱা তো কেতিয়াও হ'ব নোৱাৰা চিৰিয়াছলি কৈছোঁ এতিয়া হোৱা অলপ চিৰিয়াছ হোৱা ক্লাছ 11 টো জেনেৰেলি গ'ল ইভেন your board exam is not conduct so guys মই এটা টানকে ক'বলৈ বাধ্য হৈছোঁ okay let's start our today's class okay let's start our today's topic. We'll do a few more numericals on continuity. Check the question number 1. fx is defined as tail of 5 by 4 plus x whole bracket 1 by x where x not equal to 0 and k for x equal to 0. For what value of k fx is continuous at x equal to 0? We need to find the value of k. And condition given is function is continuous at x equal to 0. So first we need to find the limit of this function. Limit x tends to 0 of fx. We need to find this. That is limit x tends to 0. You put the fx, value of fx, tail of pi by 4 plus x bracket 1 by x. Limit x tends to 0. Tan of pi by 4 plus x. It can be written as 1 plus tail x by 1 minus tail x. 1 by x. X tends to 0. It can be written as 1 plus by tail x 1 minus tail x minus 1 by x. Why I manipulate this like this 1 plus of fx minus 1 whole 1 by x. That is limit x tends to 0 1 plus fx whole to the power gx. There is a formula of limit. You got in class 11. We'll use that formula here. X tends to 0 1 plus. I will convert this as one function. Take LCM 1 minus 2x tail x. So if you take LCM between this 1 minus 1 plus tail x, that it become 2 tail x whole to the power 1 by x. Consider this as fx and this gx. 1 plus fx whole bracket gx. Then it will be e power limit x tends to 0 fx into gx is 2 tail x by 1 minus tail x into 1 by x. This will be limit x tends to 0 that can be written as tail x by x into 2 by 1 minus tail x. In class level, you got a property of limit when u into b, limit is distributed. Limit x tends to 0, tail x by x into limit x tends to 0, 2 by 1 minus tail x. That is e power limit. Now you got the result. Limit tail x by x, x tends to 0, it will be 1 into put 0, tail 0 means 0, that is 2 by 1 into 2. It will be e power 2, e to the power 2. Okay, but in question it is given that fx is continuous at x equal to 0. So functional value 0, f of 0 equal to k. It's defined in the question. Functional value is at x equal to 0, k. As function is continuous at x equal to 0, therefore f of 0 equal to limit x tends to 0 of fx. So it will be f of 0 is k equal to e power 2. That's your result. It's very important question. This type of question are asked in JEE exam. It's very important. Check the next question. Find the point of discontinuity of y equal to 1 by u square plus u minus 2, where u equal to 1 by x. Y is a function of u and u is a function of x. That means y is a composite function. Solution. The function u equal to f of x. U is a function of x. That is 1 by x minus 1. Clearly we can see that it is discontinuous at x equal to 1, because at x equal to 1 the function is undefined. Is discontinuous at x equal to 1. The function y equal to z of x, that is 1 by u square plus u minus 2. This can be factorized. That will be u plus 2 into u minus 1. The zx function is discontinuous at u equal to minus 2 and u equal to 1. We got the value in terms of u, but we need to find the value in terms of x. We know u equal to 1 by x minus 1. Well, check the first condition, u equal to minus 2. That is, value of u is 1 by x minus 1 minus 2. Simplify this, 1 equal to minus 2x plus 2. That will be x equal to half. when u equal to 1, that is 1 by x minus 1 equal to 1. It will be x minus 1 equal to 1, therefore x equal to 2. Hence the composite function y equal to g of fx is discontinuous at 3 points: x equal to half, 1 and 2. Here's the question: if fx defined as 2x plus 3 comma while x less than 0, 0 while x equal to 0, and x square plus 3 while x greater than 0, discuss the continuity of fx. Check the solution, how we can discuss the continuity of this function. First function is given this: for greater than x greater than 0 and less than 0, function will be remain one function and it will be easily continuous when value of x is less than 0. Then the function define only this term. So left hand limit and right hand limit will be equal and its functional value will be same, which we defined by only this function. So it will be a continuous. For greater than 0, the function will be defined by this one. So in that case it will be also continuous. Now our point is x equal to 0. Now we need to check the continuity at x equal to 0. At x equal to 0, left hand limit x tends to 0 negative of fx. Left hand is less than 0. We'll apply this condition. Now fx will be 2x plus 3. Put the value of x equal to 0, that will be 3. RHL will be limit x tends to 0 positive of fx, x tends to 0 positive. In place of fx now it will be x square plus 3. Result is 3. Left hand limit equal to right hand limit. Now we need to find the functional value. F of 0 is 0, which is not equal to limit x tends to 0 of fx. So function is not continuous at x equal to 0. Let's check the graph of this function, how it look like. X dash, y dash. It is the point 0. Functional value is 0, f of 0. And for x less than 0, function is x less than 0, function is y equal to 2x plus 3. Up to it is the point 3, not exactly 3. Up to this the function is like this. It is defined by y equal to x square plus 3. It is the break point, or in that point the function is discontinuous at x equal to 0. The functional value is 0. That's the point 0. It's very simple. So we will continue. We will calculate like that. The function is continuous at all points except x equal to 0. This is our result. Check this numerical true. If fx is defined as greatest integer function of x, where this square bracket denotes the greatest integral function, then check the continuity on 1, 2. Solution. First we'll check the graphically. First draw the graph of this greatest integer function. 0, 1, 2. X-axis, y-axis, 1, 2. The function defined as this, in between 1 and 2, greatest integer function. 1 to 2 will be like this, up to 2 it is not equal to 2. This is the graph. Graphically, fx equal to greatest integer of x could be plotted as like this way. You can plot the greatest integer function here in the graph. Fx is continuous at all the points where this line 1 and 2. In between in between 1 and 2 not equal, the function is continuous. So we need to check the end point. Now we need to check the end point, that is at x equal to 1. We need to check the continuity. F of 1 is 1. RHL limit x tends to 1 positive of fx. Positive means greatest integer function, that is limit x tends to 0 positive of this, it will be 1. Greater than 1 will be 1 result. Definition of greatest integer function. LHL we need to check in between 1 and 2. Fx x tends to 1 negative. This 1 negative is slightly less than 1, so it will be 0. Therefore, at x equal to 1, function is discontinuous. Now we need to check at x equal to 2. F of 2 is 2. RHL is equal to limit x tends to I want to clear one thing here. The point starts from 1, so we don't require to find the left hand limit. It's not required actually. The function itself starts from the 1, and x equal to 1 function is, so function will be continuous. Only here we will get the right hand limit. Why? Check the function. It starts from 1. there is no value less than 1. Okay, the condition is given, that's why x tends to here 2 positive of fx, that will be 2 positive of this will be 2 negative of fx it will be 1. So fx is discontinuous at x equal to 2. That's our conclusion. Okay. Lastly, we will discuss a list of continuous function and interval in which function is continuous. We'll check. A constant function, that is c, it will be continuous anywhere, minus infinity to plus infinity. X to the power n, l is an integer greater than or equal to 0. So it will be minus infinity to plus infinity. X to the power minus l, comma, l is positive integer. It will be continuous between minus infinity to plus infinity minus 0. Or modulus of x minus a, that is minus infinity to plus infinity. And function, polynomial function px, a naught x to the power n plus a1 x to the power n minus 1 an, it will be continuous between minus infinity to plus infinity. Or rational number, or it's also a polynomial, both are px and qx, where px and qx are polynomial in x. It will be continuous between minus infinity to plus infinity, excluding qx equal to 0. This sin x minus infinity to plus infinity, cos x minus infinity to plus infinity. You can verify these all by finding their limital value and functional value. Tan x minus infinity to infinity, excluding 2n plus 1 pi by 2, such that n belongs to integers. Similarly, cot x minus infinity to plus infinity minus n pi, such that n belongs to I, integer. Sec x, similar, minus infinity to plus infinity, excluding 2n plus 1 pi by 2, such that n belongs to integer. Similarly, cosec x minus infinity to plus infinity, excluding n pi, where n belongs to integer. Or ex minus infinity to plus infinity, log x, natural log x 0 to infinity. Why 0? Because negative of log is undefined. Okay, thank you.